We're back.
Hi. And we're clueless. Oh, gee whiz. Some real quick things I wanted to go over briefly about the bits, and we got a little bit out of the order we wanted to do this, is there are some real important features to pay attention to. The bits we're showing from Velapac, and I mentioned to you they were really the first to pay attention to the needs of the solid surface industry.
Right.
But there's a lot of things that came out of that particular relationship. They really got ahead of the curve. And I know that Bob Urker had really provided me with a lot of information, and I wanted to share it with a lot of guys out there because a lot of it is safety related. And, you know, I've had my own business, and I've worked around the tools and this material for many years, but I'm still amazed. There's so much to learn every day. Bob was, in talking to me about these bits, one of the things I'd always known but I never really understood is solid surface is considered an abrasive material.
Right.
And I never really understood what that meant until we were having a discussion about it. The fact that solid surface has so much ATH in it, that is its main component, really roughly about 60% of the total material makeup. Mm-hmm. But ATH is alumina trihydrate. It's a mineral, as a matter of fact, used to make aluminum, but because of its abrasive quality, it dulls bits very fast.
Very quickly, yeah.
And so, because of that, you really have to pay attention to the carbide that is put on your tool. And carbide is not all the same.
Right.
I was fascinated to learn that. Now, I know that Velapac uses a C2, what do they call it? C2 micrograin.
Right.
Carbide. And what
that's like a super sharp. The micrograin makes it super sharp, right?
Well, no, the micrograin actually makes it more flexible. It's the way that it's molecularly altered during manufacturing, because carbide is a very hard, rigid material. Yeah. So if you use like a C4 carbide, which would make it very hard, which in turn would make it very brittle, much like in the solid surface industry. Some fabricators complain about polyesters versus acrylics, because polyesters are harder and therefore more brittle.
Glass versus plexi. Exactly.
Same thing. The harder the carbide, the more likely you are to have problems with it. Like going to a C2, once again with the micrograin in it, the carbide is more flexible and less likely to break up during cutting. And some of the problems they have are what they call flaking or chipping. So it's a superior type of carbide. Most all the carbide that Velapac uses is manufactured in Germany. They told me roughly about 75% of their carbide comes directly from Germany. The other thing that I was really fascinated to learn, and this applies to saw blades too, everybody wants to know how many feet you're going to get as far as cut before the bit is dull.
Right, what can you expect?
Exactly. It's not about how many feet you can get as far as cut. What's more critical is the quality of cut you get. So if you were to break it up into A, B, C, D, and D finally being either throw it out or get it sharpened, and A being that it is just at its prime condition, what you're really looking for is as much A cut, a good amount of B, and then at C you want it to go out to sharpen, because if you run it to D point, you might as well throw it out. Whereas some cheaper carbides will have a very short A period of cutting. It'll go rapidly into B, a little bit more of C, and then you just run it to D and you throw it out.
Okay.
So what you want is it's the length of consistent quality cut that you're after. How much of that will it deliver? And you need to pay attention to that, because that's really the time when you need to get the bit sharpened up. The most difficult bits are profile bits. One thing that I was really fascinated, and I was telling John this a little bit earlier, on a half-inch bit like this, and this applies more to the bearings, which we're going to talk about shortly, but on a bit like this outer portion of the bit might spin at about 34 miles an hour when you are running at about 21,000 RPM.
At what diameter? Half inch?
A half inch.
Okay.
Half inch shank, half inch diameter. This outer portion will run at about 34 miles an hour.
Right.
Once you get out to a 2.5, 3-inch diameter bit.
Okay, so that would be something like this.
Correct.
Okay.
Or like this.
All right.
This outer point is actually moving, I believe it was at, I believe 400. Does that sound right?
No.
Is that what did I tell you?
Look at your notes again.
I'll look at my notes again.
Maybe?
I'm sorry, 200 miles an hour. 200, but that still is pretty fantastic.
That's fast.
So that is something to pay attention to, because I know a lot of guys, when they're running larger bits, They don't understand why you just can't get a larger profile bit. And I know Velapac, from my experience in the past, from trying to get them to make custom bits, will not make the larger bits, and that's why.
But some manufacturers will.
But there's so much stress introduced into the carbide that your concern is, can the bit even withstand that? But not even. But there's other issues too that we'll get to here just shortly. But that's one kind of important feature I wanted to hit briefly on. Also, just very briefly, there are some things you really want to pay attention to when you're running your carbide bits. Almost all failures, something else I was intrigued to learn, are collet related. Right here. I did not know that you should replace your collets.
That's something that I didn't know.
The collets,
I don't think I've ever replaced a collet. In all the years that I was a fabricator, well, not a fabricator, but a plastic laminate fabricator, we never replaced collets.
Well, some of the things I learned about collets, and some of it is intuitive, it makes sense once you hear it, is all collets are self-releasing. Whoop. Helps if you use the right size.
Right.
But when you release the pressure on the bit should just sleeve right out, as it should sleeve freely in.
We always tapped ours with the wrench.
That may tell you something. Usually when your collets are brand new and the bits are new, you always notice they tend to release them, just drop right out.
Right.
It's as they get older that they tend to start to freeze up in there. You've noticed that, haven't you?
I know exactly what you're talking about.
And it goes bad on you. So the ability to get your
Could
bit
you
out.
use lube on that?
That's right. The ability to get your bit out is important.
Right.
So you may want to talk about that a little bit more.
But no, actually, but don't miss this. The amount that the router bit shank goes into the collet is critical, because you don't want to have this just part in, and you can look at your collet and determine, how deep it is, and then just look at your router bit and say this much has to go in order to get the full use of the collet. If you're only using half of the collet, it's, instead of clamping like a parallel clamp. What are you smiling about?
Nothing, I'm listening.
Instead of clamping like a parallel clamp, it's going to clamp at the outside, and it's going to be on an angle. So it's not going to have the hold that this does. Come on, move along here. Don't get me going.
So,
I said we'd have a serious show tonight.
You want to make sure, once again, but really, John's right. You want to make sure that you get the shank fully into the collet.
Very important.
Otherwise, you're not
Full
taking...
penetration is critical.
So, anyway, pay attention to your collet. Your collet is your friend.
That's right.
Treat it well.
That's right.
But you want to make sure that the bit is fully inserted into the collet. Otherwise, the collet won't hold the bit. And if it doesn't hold the bit, then it's just going to fly out, and you've got a problem.
Right.
So check that. And the minute that it begins to freeze in the collet, or the collet isn't working right,
here. We've only got a couple minutes
I know
before
that.
the show.
I know that's just so many things to do. If you find the collet,
we could have talked about router bits all night long.
We could have.
Seriously.
If you find that the collet is scarring the shank,
right?
You know what you need to do? You need to throw your collet out. What else do you need to do?
Get a new router bit.
Throw your bit out too.
Right.
That was another thing
and buy a new one from us.
But it's a sickening thing for a fabricator to have to be confronted with that. But the problem is, don't try to file this. Don't try to sand it to correct it, because you're distorting the shank, and then even a good collet won't hold it.
And actually, the thing that you've got to keep in mind is that if you do have a bad collet, especially on a large diameter bit, and these are expensive, these are $100 plus, there's more chance that you're going to damage this router bit in a bad collet than in anything else. Mm-hmm. So, I guess that's important to have an extra collet on hand and inspect those once in a while.
Exactly. Another thing too, and now we're kind of starting to get a little bit out of it, but trying to pay attention to the time here. The size of your shank is critical. You're a bad person. If I notice your wife has gone home, that's why you can act like this.
I just laughed.
The size of your shank is very important.
Okay.
Because if you have a little shank, if you put it under pressure, it won't stay in the collet. So when when cutting hard materials, you want to make sure that your can we go on live, please? The rigidity of the shank is important, because if your shank is not if the shank
I can't stop. I'm sorry.
I hate my job. Okay, I'm going to do my best here to continue this line of thought.
Okay.
If your shank is not a sufficient thickness, it won't retain the rigidity that it needs, and you won't be able to get the cut. And the cut is critical, especially, once again, in high abrasive solid surface materials. So the rigidity is the key on any router bit. If you don't maintain, that's the way the whole show's gone this last half. If you don't maintain the rigidity, you'll get a very poor cut, which will introduce a lot of stress into the collet, which will wear your collet out and will ruin your bit, and it's costing you a lot of money. So rigidity is really a key. And the other thing too is you can actually feel that. You guys that have run routers an awful lot know exactly what I'm talking about. It's not only how it feels going into the cut, but it's also how it sounds. So you want to, are you back? Are you going to be a good boy?
Yes, I'm back.
Your back is badder than ever.
Oh, I'm sorry.
So you want to,
I'm sorry.
you want to, you break my train of thought when you come back. You should have stayed away. But you really want to go by how the bit feels, because I'll tell you, if you begin to hear anything at all that doesn't sound right or doesn't feel right, and that includes even a saw blade, because you can lose a tooth while you're cutting. So you don't want to lose teeth.
That's right.
But the same thing, you can begin to lose carbide, which can throw the bit off, and it won't perform correctly. The other thing that's really critical to that feel, and we've talked about this some, but we've got to talk about it when we're talking about the different bits, both bowl bits, two totally different configurations. But you can see these Delrin bearings at the top.
Actually, I don't think they're Delrin anymore. Aren't they
Nylon.
Teflon or nylon?
Nylon.
Okay.
And the key,
Delrin cracked after a while.
Yeah, I think Delrin just kind of is there because it's become a generic term.
Right.
But this nylon, I was fascinated to find out from the manufacturer, there's no guarantee on the performance life of the nylon on the bearing. It may last 3 inches, it may last 300 feet, it may last 3 miles. And the problem is there's so many variables to its failure. But that's something you want to pay very careful attention to. You want to make sure that it's always well lubricated and free moving. That is very, very important. But that also applies to a metal bearing. You like the way that works for you?
It's nice and smooth.
There you go.
It is.
Got a nice roll to it, doesn't it?
It's got a good feel to it.
And now that's one size metal bearing, and there's another. But you want to pay attention to how those bearings are performing, because if you start to get the feeling that something isn't right on the bit, that it starts to get rough or something, you want to stop your cut immediately, because the object is to help save your
like
work.
We said last week, that lubrication is key, always, with a router bit, absolutely. Well, with a bearing, rather.
And I want
really quickly, we got to get in these. We only have a couple minutes
Go
left.
ahead, talk about it.
Okay, insert bits. Why are they better? Couple of reasons. On a straight flute, well, they're making these in different profiles as well now, but the biggest thing that we found out in asking questions about these is, since this carbide has not been heated, it's actually, is it stronger?
Stronger. It's stronger.
It's stronger. It'll last longer. So these are one of those tools that it's pay me now or pay me later. You're going to pay a lot of money up front for the holder, but the router bits are actually, they're two-sided. You flip them over, you screw them in with these 2 screws, and then they're sharp again. So you don't have any downtime, for one. There's never a size difference, and this is with a flush bit with a bearing, the size of the bit is critical in relationship to the size of the bearing. The more times you get a flush cutter sharpened, the smaller diameter it's going to get. That's not the case with an insert bit. Insert bits are absolutely less expensive in the long run, it's better in the long run because you're always making a flush cut. You always have sharp bits because it's easy to just say, oh, my bit's dull, turn it around.
Or the inserts also come like this. These are the inserts for that particular
bit. Right, you
bit.
buy 10 in a box.
Correct. And the price of these are really about pretty close to the price of a good bit.
And these are sharp on both sides.
Mm-hmm.
So out of one of these, if you have a single flute bit, out of one of these, you're going to get 2 router bits. The cost of 2 router bits.
You can also get this. Now, this happens to be a bottom bearing, but you can also get this in plunge.
Right. Yep.
So one of the things, and I'm slow to learn some things, unfortunately, but I would have to say from a fabricator's standpoint, if I still had a shop, I think these would be the type of bits I would be using now. I would stay away from these altogether.
From a fabricator's standpoint, yes. From a distributor standpoint,
No.
we wish you wouldn't buy them. But it really, I mean, it's really the best cost, the best bang for the buck when you're talking about, you know, spending money and getting the most for your value for money.
Mm-hmm. So a fantastic a bit. One of the things I want you to get to
Let's
quickly.
cover those next week because
Okay.
we're just about out of time.
We have only 1 minute left.
Right.
And we probably would have had time if we didn't melt down on you, but.
Well,
But
we're sorry about that.
That's part
but
of what makes
sometimes
it kind of weird to watch us because you don't know what, you may not want to know what goes on, but we'll let John explain how this has been used in the farming industry. And was it dairy farming?
No, it is sheep farming.
Okay. So make sure
So we'll talk about these next week, guys.
Make sure you have your rubber boots.
We want to thank you for joining us. Our product code for this week is
01 0
1
8
08. That's right.
01 08.
Right. 07.
Excellent. You got it.
Okay.
01 08 07.
And we'll be running 10% off all saw blades, all manufacturers that
Linby,
we carry,
AEG, Amana,
and all the router
Poplar.
bits that we carry. Anything except for Festool again, because we do carry Festool blades.
That's correct. Again, so that actually makes your favorite Velopec bit a great deal this week.
That's right. So, thanks, and we're out.